Okay, let's continue the class. Let me share the screen first. Entire screen share. Okay. Okay, so that's you cannot get on screen. Okay, so this is the unsupervised learning. Basically, it tries to cluster things. Okay, but I use image, so it's easier to understand because image we can see the actual things. Okay, if it is numbers, it's more difficult. So image is much easier to see things, and we can see the cluster very easy here. We can understand the clustering. Basically, the clustering is try to minimize the distance between feature in one cluster. Okay, now the actual okay, I remove these things. So the actual flow is something like this. So this is actually the programming flow. So we have sensor or widget to read image, and then we can calculate the make actually this is the calculation process, the modeling process. Okay, and then the last one is the visualization process. So basically these are the main ID behind machine learning. Get the data, modeling, visualization. That's what normally done like this, but we can modify if we use prediction, if we use what else, we can modify things, but the simplest one is like this. Okay, now I can always change the program. For example, I can remove the these things if we don't want to analyze image. These two are still the same. Distance and cluster the same. Of course, we can use different algorithm. We have PCA. We have what else? K. Do we have K something? K-means. Uh, there are several algorithm to do the clustering. Okay, but the difference the this one PCA is different. Basically, it try to reduce the number of features. Okay, uh, let me see if I can do that here. I don't know. No, no. Okay. Let me see if we can do the. Okay, so we have the data set here. So I like to see the so variable is basically the features. This one it has 16,000 features. Okay, this is very. This is leukemia, cancer, chronic lymphocytic leukemia peripheral. I don't know. Okay, so let me see if I can play around with these things. Okay, so this is brutal. It has 16,000 features and very difficult to analyze. Okay, as it is, it's very time consuming to analyze. So we have we can see the data table here. See, we have control 222968 at 223641 at I don't know what it is. This is like medical stuff because Orange developed by biomedical bioinformatics. So basically, this physician they are having difficulty to deal with their statistics, so they built Orange. So we have a feature, and the target is very simple actually. The target disease states is chronic. So this must be the target. This is states. Oh, this is the class. Sorry, this is the target. The class. Chronic lymphomia, leukemia, they are normal control. There is a chronic one, there is a normal one. Okay, so we have two different values. Okay, this is what you call it? This is supervised learning, but we can treat this as unsupervised. We can ignore this thing, and then we can compare whether our classification match the unsupervised. We can check whether the unsupervised will be matched with supervised. Okay, let me see. Let us see whether it works or not. Okay. See this? I can fit directly to distance, and we can check the cluster directly. Okay. Now, these are the cluster generated by the feature. Now, the annotation, I change the annotation into class. The annotation into class. Okay. See this? So the blue one is basically the chronic lymphocytic leukemia, except this one. This is normal, but classify as chronic. Okay, and also we have this one. These are normal, except this one. So one is for in each category we have one miss. Okay, so this is the error. So we have these two error here. Okay, so basically the result from unsupervised learning is very similar to the supervised learning. So this one is unsupervised. We use distance, and we find the result is very similar. And we find there are two at least errors here. This one is the normal control, and this one is the chronic lymphocytic leukemia. Okay, so we have to understand. Okay, the algorithm may produce results, but the results is not 100% accurate. It may be like, I don't know, the accuracy not 100%. So basically, we have to keep that in mind, that the accuracy is not 100%. So we have some errors. Okay, so that's it. Okay, so the basic method is the same: distance, clustering, and this data set. Of course, because we have 16,000 variables, we can use PCA on this one. Can remove this, and then we are unsupervised. We have PCA here. Let me see. Where is PCA? Okay, this one is PCA. Okay. Oops. So we can select using PCA. We can select how many variables we want to have. So basically, we can reduce from 16,000 to, I don't know, 4, 5 variables, 4 or 5 features, if you like. So it's try to fit. So it's working hard. So the algorithm is working very hard. Wait, okay. So it's working very, very hard because it's trying to reduce significantly from 16,000 to, I don't know, I think it's 3 or something. 3 or 2 variables only. Of course, because we shift the coordinate, basically, of the features. Okay, it's finished. Let me see how many. Okay, so we have 3. Okay. It using 3 component. Out of 16,000, we reduce into 3. Okay, but it can explain like 56% of the data. If we increase into 5, then we can have more. Let me see. But we have to wait. No, I don't want to wait. So basically we have 3, but we understand that this will not as precise as 16,000. But from computing point of view, this is much better than dealing with 16,000. So that's the basic idea of PCA. So we map the 16,000 into 3, and we don't have to deal with 16,000 variables. We can deal only by 3 axes, and then fit this axis to distance. Okay, much faster, and then we can see the cluster here. Same. I use class. See, same here. One error here. This error is gone. Wrong. So, but at least we can tell that, well, okay, it seems to classify quite good. Oh, still we have the error here. Okay. Still we find the error, and then the error still remains, and the rest is okay. So seems to be okay. Okay. So we can reduce from 16,000 feature to 3 only. So from computational point of view, this is much better approach. Okay, so that's PCA basically. Okay, so we can reduce the 16,000. Of course, we can change the. So you check these things, these variables things. This is like breast cancer. It has like 9,000 variables. Smoking effect, 3,000 variable. We can play around with these things. Okay. Most of them are, if it says categorical, that means it's supervised learning. If there is no categorical, like this one, Parliament is no, sorry, HDI, there is no categorical, that means this heavily unsupervised learning. Okay, so we can tell the type of data we are dealing with. So some of them, wow, this is more brutal. This is molecular taxonomy of breast, I think breast cancer or something. Let me check. Yeah, breast cancer. It's not, no target, unsupervised learning. Okay, so so this is unsupervised learning. If we want to move into supervised learning, we can remove this. Okay, this part is supervised learning. We can just change this into, this is unsupervised learning. We can move into supervised learning. Basically, in supervised learning, we want, yes, we can classify, but we can also do prediction. If we do prediction, then we need to generate the model from the data set. Okay. If we want to have for clustering, better unsupervised. If we want to say the group, the cluster, so unsupervised is much better because it has the facility to show the cluster and so on. Okay, for example, we want to do the prediction, so we can do something like this. Evaluate. We can check the algorithm, which one. Oh man. Okay. Oh wait. Okay. Oops. It's very slow. Okay, let me see if I can connect this two. Okay, I can connect the test score. Basically, this is the way we evaluate which model is best. Of course, you can do this. You can do the same thing using Python, but this is the easiest way to give some idea how the algorithm works. So we can select which algorithm we like. Of course, many of the other lectures may introduce you with neural network. This is their favorite, basically, neural network. I'm not really keen into neural network personally. Yes, it works. It's good, but it requires a lot of computing power. Sometimes we need GPU and stuff like that. That's too heavy. Okay. If we want to deal with like small data, the other algorithm may be sufficient because this is like only two value of category. I can use logistic regression, and then I can use naive bias as well. Okay, let us check which one is best. Okay, so we fit the model to the test score. The neural network may okay, takes a long time here. Okay, this one takes a lot of time. Neural network. Okay, logic regression. So it check all of these algorithms simultaneously, and then it will show you. Oops. So this part is not used. So we can play around something like this. We can ignore some of the part. If you like, we can remove this thing as well. No problem. Still 9% because of this one neural network takes a lot of time, and I'm not allocating too much core memory, core CPU, as well as memory to this virtual machine. Okay. Okay, 19%. Let me see. So after we finish that we can do prediction if you like. We can do prediction, we can play around with it, we can check the confusion matrix and so on. Okay, remove. Okay, we can check the confusion matrix as well. Confusion matrix basically to check how confused the algorithm is. That's why it's called confusion matrix. Wow, man, that takes a long time. I can remove this one. Let me see. Remove this one. I give up. Oh, okay, 29%. I nearly removed the neural network because this actually takes a lot of time. Takes a lot of CPU and takes a lot of time. So neural network is uh, very famous to consume your CPU. Okay, 39%. So next week, I have to. Next week, I will not be in Jakarta actually. So next week, I will be in Sumedang, different cities, small cities. On Saturday morning, we will have a talk show for the so this is next week. We will have a talk show with small medium enterprises in Sumedang area with the not government, right, the municipal head of municipal, as well as the special staff of the president on AI. So I will talk about that next week. So because of the traveling things, so next week I will do the class from Sumedang, not from Jakarta. So the problem with that, the internet may not as good as this one. So next week, so be aware that my internet is not as good, as well as my laptop is not as good as my PC. This is my PC. This is much better than my laptop. So I will not be able to run map Orange and so on. So Orange is skipped. So next week I will fully on Python, Google Colab because of that. So next week and the week after I will be focused on Python. 69% still running. So this is the troublemaker actually neural network. Let me see if I can see this. Okay, so in neural network, we can change many things here. We can set how many layers in the neural network. We can set the activation function. We can set the solver. Okay, we have several solver here. you can check the difference in ChatGPT and so on. What's the difference between Adam, SGD, LB, FG, SB? What's the difference? What is the difference between ReLU, tangens hyperbolic, logistic, and identity? Okay. Uh, Identity, you can check in chatbot, sorry, ChatGPT. Basically, if we are dealing with ReLU is the most what's that favorite activation function because it can deal with linear problem as well as non-linear or classification problem. Tangan hyperbolic and logistic basically the for classification only. Identity is for linear only. Okay, so basically this. But we can play around with it and then see what's the results from these four activation function. The number of iteration set how many iteration it will try to optimize. If it is not converge after 200, it will stop. So this is basically the number when it will stop. We can do the same thing using Python actually. Okay, so but this one it's much simpler. Python is more complex, but then you can have more freedom. So for example, you can drop the sum of the node, how many percent node will be dropped and so on. So we can do a lot of fancy things using Python, and this one is much simpler. Okay, man, back to 90%. Okay, I give up. I remove this one. I hope it's much faster. So neural network is very famous for to make things slower. Okay, 24 still running. Okay, because this is too many data. Okay, I remove this one as well. Okay. Wow, man, takes a lot of time. Woo. Okay, I think I have to give up. I have to use PCA on this one. Otherwise, it's difficult because the number of feature is too much, like 16,000. Let me see. No, I think I gave up. Okay, give up. Okay, too much. Remove. Okay, sorry. Okay. Now, change little bit the code. So I need to. Can I do these things? I think I can do. I can do PCA here. So I use PCA in supervised learning. PCA normally designed for unsupervised, but I try to change little bit because I have to do only like 3 features on this one. But then we need to uh, what's that? To manipulate all the data using the same PCA like this. If we want to so that's make things more ops. Okay. Wow. Okay, we are dealing with like huge data. It's with now to make things more complicated a little bit. I need to do this data sampler. Okay. So basically, data sampler will split the data into 2 different data. So fixed portion of data. So basically, I can set how the percentage for training data and the percentage for testing data. So from the same data, we can, using this data sampler, we can use part of the data for creating the model and part of the data for testing the model before we actually deploy the model for analyzing the other data. So basically, we can test whether our model is good enough or not. So right now, I mix fixed proportion of the data, like 80% for this one, fixed proportion. So 80% for, I think 80% for training data and 20% for testing data. So okay, then we can test. Okay, now from PCA, we can go to this one if you like. So we have 80%. Let me see. Data sample, remaining data. So data sample, okay. So I test the 80% to test score and test for 3 different algorithm, 3 random forest and logistic regression. Which one is best for testing this data? So it's 33% now. I hope it's faster than that. 49%, okay. 66. Let me move it here so it's easier to see. So we have 3 algorithms to test, 82%. So basically, I changed the number of features from 16,000, I don't know, 16 or 18,000, I forgot, to 3 only. And then 80% fit to the test for testing which algorithm is best. Okay, it's okay now. So the best one will be 3. 3 is the best one. It give, oh no, logistic regression is the best one. I can click precision and then we can, oh sorry, the other way. So we can see logistic regression for this particular data. We can see the logistic regression is 97%, close to 98%. You can change the fold into several more folds. But then I have to wait again. No, I don't want to wait. Basically, we know the logistic is better. So I remove the, I don't want to wait. Sorry, remove. Okay. Okay, remove. So we know already that the logistic regression is the best. Provide good results like 98%. So I fit this data to this one, data sample to this one, 80% to logistic regression, and it will give you the model. And let me see if I can play around with the other 20%. Let me see if I can get the confusion matrix here. Can I? Oh, confusion matrix must be from the test data, not this one. Okay, anyway. Okay, the prediction. So basically, we have the model from the 80% of the data, fit the model into the prediction. Okay, so we have the prediction will receive the model from the logistic regression with 98% precision. And the rest of the data, which is only like 20% here, I will fit into prediction. I want to see how well the model works. Oops. We have to wait. Oops. Okay, this is the results. Okay. Basically, very good. The precision is 100% precise. Okay. The error is very small, but basically, the logistic regression predict this is a chronic, and the actual model is chronic as well. Normal control, chronic, normal, chronic, and all 100% precise. So basically, it's very good. Okay. So that's how it works. So let me show you the final. I remove this one. Remove. Okay. So the this one is more complicated than the normal one. So basically, I read the data, shift the features, reduce the features from what 14,000 or 18,000, I forgot, to 3. This is brutal. From 1,000 to 3 features only, and then make split the data into 80/20. So use the 80 for the modeling and fit the model into prediction. The rest 20% goes to prediction and test. And finally, we found okay, the model is good enough. We can predict 100% from these things. So this is how it works. In real world, in reality, it's not like this. Basically, this is only in reality we for example we have the data set and we create another we read another data from the different patient. This is like leukemia patient, and let me see, where is the supervised learning? Evaluate supervised. I need supervised. This one. So we read another data, do the PCA, okay, and then fit to the prediction here. So actually, in reality, this part, the 20% will be replaced by new data from the real patient. So we have the model, and we have real patient data. So and then it will predict. Okay, this guy, the leukemia in this guy is chronic. This guy is normal. So we basically read the data from real patient. This is the old data from the old patient. So the data from the old patient used as a model, and then data from new patient will be predicted by the old model basically. So this is how it works. Okay. So it can be as complicated as this one. Okay. So we can play around basic. If you having understand this, then you can modify using Python. Let me see if I can do that here. Let me see here. No. Okay, let's try this one. Let's try this one. Okay. What I will going to do is I try to screenshot the workflow of Orange and put it in Grok or ChatGPT and ask these two AI to generate the Python source code based on the Orange workflow. Okay. Okay, I will try to capture the source code. For example, this one. Okay. Okay. Let me see. I've get the screenshot. So this is how it works. So you play around first with Orange. Oh man, my drive is slow. Okay. So play around with Orange first, see things, and then okay. Okay, so this is the screenshot. 1848. Okay. Uh, Let me see if I can use ChatGPT and both. I will try both ChatGPT and Grok, and ask to generate the source code in Python. Okay, pictures, screenshots. So you don't have to develop your own code. Basically, you can play around first, try to get the feeling of the data using Orange, and then upload to Grok and ChatGPT or whatever you like, and then ask to generate the source code using. Of course, you need to modify, or you have to sign in first. Sign in using Google. Okay. Continue. Okay. Upload a file, pictures, and then screenshots. Okay. Now generate Python script based on Orange workflow in the attached file. Okay, I will copy paste to ChatGPT as well. Okay. So my advice is, if you have any data, play around with Orange first, see how it works, and see the accuracy and so on. Then play around with these things. The major problem with Orange is for neural network. The feature is very limited, so we can generate fully reproduce workflow. So it will give you the workflow. Okay, this is wrong. It thought that I use Irish data, so this is wrong. Of course, we have to. Let me see this one. This is still same Irish, man. This is not Irish data. But you have PCA here. See, you have PCA. You have and so. But this is for Irish data. Anyway, this is for Irish data. We can play around with Irish data because Irish normally is included in this one, SK Learn data set. So it has Iris in the data set in SK Learn. Okay, so we don't have to worry about uploading the data and so on. But then using Python, if we use Google Drive, if we upload our Excel file in Google Drive, then we need to ask how to connect, how to mount Google Drive to Google Colab and read the data from Google Drive. It's not that difficult. It's quite easy, but we have to do that. In this particular example they provide, it thought it's Iris. I'm not using Iris, but anyway, it uses Iris. Let me see how it works on Iris. This is Iris data. We have to change this. Oh, maybe later. Okay. Okay. If you prefer a pure Orange 3 API, we are not using Orange API. So I use pure Python on this one. So this will be our course material for next week and the week after. Okay, so we will play around with these things. Okay, so back to this one. Where is it? Okay, so this basically we have these things. Okay, now let me see if I can play around with let me see. Okay, The next things we have to cover is, so this is unsupervised. Image analysis has been covered. I will show you the text mining. To be honest, text mining is now become obsolete. We hardly use text mining anymore because of LLM. So text mining is no longer used, but still, if you want to get some idea how to get some insight of the any text, you can always use text mining. Or if you want to play around with these things, you can use text mining. Text mining, but now we can use ChatGPT or Orange, Grok for these things. So the LLM AI is very good in text mining and analyzing text. It's much better, but for simple reason, text mining can give you some fancy things as well. Okay, let me see. Okay, so I remove this one. Okay, let us do some text mining on this one. Very simple text mining. I hope it works. Okay, so here we have text mining here. Basically, we can create. It has several tags. Imported. Oh, let me see. It has some data set, corpus data set. We have several data set here. For example, green tail selected, book excerpt, French transcript, and Anderson. Anderson is the, I don't know. I am old enough. So in the, oops, I think we have in trouble here. I don't know whether it will work or not. Basically, Anderson is the book for children. I'm old enough, so in my days, I read a lot of H.C. Anderson books. So let me see if we can find something. This is book for children. It's very famous. Little Mermaid, Ugly Duckling, and so on. So Hans Christian Andersen write a lot of books for children, and then I'm read this book as well in Indonesian language, of course. And then in this particular script, let me see. Okay, in this particular script, let me see if it works. Okay, I don't know whether it works or not. We can read the import create corpus. Let me see if I can read the book, read the data. Oops. Nope, I cannot read. Okay, how can I read these things? Create corpus. I forgot how to read these things. Oh, maybe I can do something like this. As simple as this. Data table. Okay, now I can read this one. So I feed the corpus into the corpus, basically Excel file. Not Excel file. It's saved in CSV format. You can read using Excel file, and it gives you something like this. Okay. Wow. Nope, nope. This is not. This is not I want to. Oh, this is Hillary Clinton. This is tweet. Wait, no. Let me see. How about this one? This is election tweets. Wrong. Okay, how about this one? Let me see. Okay. Okay, this one is much better. So basically, these are the title of the book. Hare Corpse, Little Red Riding Hood, Mother Hole, Old Sultan, Pack all the whatever, Fox and Grease, Fox and House, Frog Prince, Golden Bird, and this is the abstract of the book. This is the actual content. Okay, once upon a time, there were a rooster and hen who wanted basically this is the actual topic. Animal tales, tales of magic, animal tales. So this is actually the classification. Okay, so from the text, we want to classify whether this text is which classification. Okay, and then we have 44 basically. We have 44 books, and we have two classification. One is magic, the other one is animal tales. Okay, so we have two values. Okay, this is book for children, so we have magic and animals. Based on the text, it has to classify which this book belongs to which classification, whether magic or animal. Okay, how can we do that? It's actually not that difficult. Okay, let me see. But before that, it can do more magic on a lot of magic on this one actually. Let me see. I can do some pre-processing of the text. I will show you the word cloud basically. Let me see, where is the word cloud? Word cloud, word cloud, word cloud, word cloud, word cloud. Document map. This one, word cloud. Let me see if I can show the word cloud from this one. Okay, so we have the actual, we have the actual text here. We have the actual text. Okay, we feed the text into pre-processing the text. Basically, in pre-processing, we can make make all of the text become lowercase. We can remove URL if you like. We can do tokenizing. For example, we can do regular expression and take all the word separately. This is you using regular expression, and we can also remove the stop words. Let me see if I can. No, not this one. Oh, it's gone. I need to load a file containing the stop words, for example, and, or, and so on. That's stop words. Okay. So we can do that here, stop words, removing. Let me see if I can. I have stop words in English. Keywords. Text. This is stop words Indonesian. Stop words ID. No English stop words. No. I need to generate stop words in English. Let me see if I can. Maybe we can do it later. I can show you what happened if we don't have. We can do removing all the comma, semicolon, apostrophe, and whatever on the text. So we can keep all the text but remove all these unnecessary things. And then, so that's basically pre-processing of the text, and then feed the final text to word cloud. See if it works. So this is the word cloud. So see, we have could, which is not, there is no meaning in could. When, there is no meaning in went. So we can remove all these things. Might, okay, might, we need to put this into stop words. Okay. Set also can be removed, so we put, so stop words is like that. Okay. To make things quicker, I will try to generate stop words using ChatGPT or Grok, maybe better. Generate or create stop English stop words in a single list. Hmm. Not list like this. So it will read text uh, for an ASCII text file. So I need something like this. Okay. Okay. So we have an elaborate stopwords now. Okay, this one is much better. We have a lot of stopwords here. Prefer this response. Okay. Now we have this the stopwords. I can text all of this here. Okay. Copy and I put it here. Orange. Thanks. Uh, words English. So that's how to create stopwords. Basically, you can add your own stopwords if you like. If you find something, some stopwords, you can put it here as well. Okay, so this is quite a lot. Okay, but may not be the way I create a stopwords. Normally, I run a Python script to calculate the number, the words, uh, how many times this particular words appearing in a text. And for example, let me show you. See this? This is you can generate a code to calculate how many times this particular word appear. So set appear 668. Set has nothing to do with the story actually. So I can remove set if you like. I can remove came if you like. When, one, king is important. Little may be important. So set is definitely has no meaning. Could have no meaning. Would has no meaning. So set could would I can put it in the stop words as well. Let me see. Set. Oh, set already there. How about could? Already there. Would there. So all these three is already there. Oh, this is double. Okay, remove one. Okay, now I need to upload this file. So I have to go here. Let me see if I can download orange text. Because these are two different machines. So I need to upload. 8, 3, orange text. Okay, it should be there. Stopwords English. So we have stopword English here. Let me redo these things. Sorry. So I can pre-process and orange text stopword English. Okay. So we add stopwords English here. Let me see the results now. See, set is gone. Now becoming more easier to see. So the important thing here is king, wife, father, day, fox, good, cried, man, mother. So these are the important words in the actual text. So we can see the text is talking about what kind of context. So that's how things using the same method, we can use, of course, we don't have to do the programming now, or you need to do just upload the file to ChatGPT or Grok and find these things. Okay, now the other interesting things with this one is actually, let me see if I can do something. Let me see. 250 more frequent tokens. Tokens like words, basically. I will try to create a graph picture of the words. Basically, so the word cloud, we can see only which word is the important ones. Okay, we can see the important words in the text using these things. In the actual text analysis, we normally want to see the context. These particular words work with with which words. So one word collaborate with what words. For example, house. No, in Indonesian, house is hospital is rumah sakit, sick house. Okay, so we can check this particular word work with which word. Okay, so in this one, in word cloud, we cannot see that. So the correlation, the context of this particular words is not visible in Orange Cloud. But I want to show you the network, the graph. Where is it? Yeah, this one, corpus network. Let me see if I can do something like this. Okay. Node type is word, threshold 10, word size is 1, frequency threshold. Okay, let me see if I can fit the pre-processed text into these things. 0, oh well, man. Let me see if I can reduce. Okay, now we can see something. Okay, still 200, 160. I can increase the threshold. So I need to see like only smaller number of nodes. Okay, how about I increase to 60? 45. How about I increase to 80? 22. So this one is much smaller, easier to see. So we have a network with 22 nodes. Let me see. Oh, okay. So these are the nodes, the words. Father, time, set, thought, and then see how the connection between one and another. To see these things, we need to use network. Okay, we have the actual network. Can we see using this one? I don't know. I forgot. Has been long time ago. Network. Uh, let's only show you the actual network. Let me see the network explorer. Okay, now we can explore the network like this. So basically, time normally related with long. Okay, good day, wife and man. So this is man and woman. Beautiful with bird, and this is the interesting one. King, son, home, father, mother, house. Okay, let me see if I can. I can scale up these things or zoom. Okay, see this? We can see. Okay, oh, okay. That's how. So we don't have any, not much connection. So this is very sparse connection. I can increase the connection by changing these things actually. It's too small. Let me see. I reduce to 40, 79. Let me see if I still. These are the main focus of the story. It talks about son and king, father, mother, house, home, daughter, morning queen. So these are the major words correlate with these things, with the story. Okay. Now, as I mentioned before, we have like two type of the story, animal and magic. How can we differentiate between these two? Okay. Now we need. Okay, I remove this one. This is basically for viewing the words. Okay. So after let me see. Yeah, after pre-processing text, after we do the pre-processing text, I remove the most frequent tokens. So I will have all of this story, 44 stories. And then what we normally do, we will try to embed the text. This one, back of words. Okay. So basically it will calculate one particular word how many times show up in the text. Okay, so it will create, so in the uh, current method, normally we call it embedding. Okay, so basically we try to create a coordinate of the word. Okay, so word A, how many times in the text, word B, how many times in the text, word C, how many times in the text. So we have the uh, coordinate of this particular word. Let me see if I can show it to you. See this. So a court one times, afraid one times, ago one times, and so on. So we the embedding will add these things actually. Okay. Now we want to measure these things and we'll correlate these things into these topics here. But to make things interesting, I will split the data. Let me see. Let me see if I can split. I, I want to split the data again. So 80% is training data, 20% for testing data. Okay. So let me see if I can do. All the data is text actually. So the data is text. Only this ATU numerical is number. The rest is text. So we are dealing with text data and classification. So we have to classify text. Okay. Now let me see if I can. So we have split the data into 80%, 20%, and then we want to check the algorithm, which one is best. I think the best one can be logistic or tree, or let me see. Okay, evaluate. We have test and score. Okay. So we fit the 80% into, let me see if it is correct. So, okay, data sample, 80% goes to data. We keep the remaining data. We are not using it. And then we want to evaluate several models. So we want to check using my favorite one, actually, random forest. random forest will normally give you good results. 3. Okay. By the way, you can always try to analyze things like text using ChatGPT and stuff like that. But sometimes to do machine learning, better to use this kind of approach. So ChatGPT and Grok and all this AI, LLM AI, sometimes will not give you like very simple way to analyze things. I normally use this one, machine learning, to analyze text or to classify things. But then to write the report, ChatGPT, Grok, and so on will help a lot. So let me see. Okay, still 60 something percent, 75%, 79%, 82%, 85%, 92, 95, 100%. Okay, now let me see. So the most, okay, in this part, not random forest. Logistic regression is much better because we only dealing with 2 category. Okay, either it's magical story or what's that? Magic and animal. Okay, because it's so simple, logistic regression is much better, still much better. If it is has more classification, sometimes random forest will give you a better results. On this one, logistic regression give you better results. It's 86%, 89% precision. Okay. Also recall is much better in logistic regression. So the better one is logistic regression. So I will select logistic regression, remove these 2. Remove. Okay, remove this one. Remove. Okay, so we have this one, logistic regression. So we have the model. I will move it here. Preprocessed text, back of words, then data sampler, then so these 4, corpus, preprocessed text, back of words, data sampler, basically preparing all the data. The actual modeling only this one, logistic regression. Okay, I'll remove this one and remove this one. Okay, so this 4 is the for preparing the data, modeling the data, and we will do some prediction. Where is the prediction stuff? Okay, this is prediction. Okay, fit the model to the prediction, and I want to fit the okay, I put it here because it's easier. Okay, so the 20%, the rest of the remaining data, I put it here. Okay, wrong. I have to, this is data sample and this one is a data sample. It's not good. So I have to change this one, remaining data. Oops. Okay. So remaining data. Okay. So the 80% goes to logistic regression. So it will model based on the 80%, fit the model into the predictors, and then 20%, the rest of the data, remaining data, goes to the prediction. See what happened here. Read this one, the table below. The precision is 100% precise, actually. So the actual data says it's magic. The logical regression says magic. The actual data say tells you it's animal. This one animal, magic, 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 magic. This is 100%. Okay. What happened if we change the algorithm? It's okay. We change the algorithm. Let me see if I can say. We use random forest. Okay. Okay, data sample, 80% goes to random forest, goes to here. See what happened. Do we get still 100%? So we still have 100%. What happened if we change into, this is random forest here. Okay. So that's how to play around with these things. Okay, remove, and then I change into, maybe I choose something bad. For example, this one, naive bias. Naive bias is not very good for these things. Let me see if it works. Okay, data sample, fit the model. Oops. Fit the model to the prediction. What happened here? So the precision only 14%. It gives you all the animal tails. So that's what happened if we have bad model. Okay, so that's why we need to test first using test score, and the precision is very important here to see whether our model is give you like precise results. Okay, so we are dealing with text here. So we need to do the embedding first, then we do the actual text. I don't know if we remove the embedding, what happened? Remove this one. I change this one. Use the better model. Sometimes it works. Sometimes it's not. Let me see. Where is the model? I need my model here. Okay, this is logistic regression. Okay. Data sample goes to logistic regression. The model goes to prediction. Okay. Now we remove the embedding, the back of words. Let me see if I can fit directly to here. Confused. Doesn't work. Okay, so that's what happened if we are not embedding the so basically the text analysis, basically it calculate the coordinate of the text. So basically we create what the back of words. Basically we creating space, coordinate space, they call it embedding, of particular text, so we can see the factor of a particular text. If we don't do that, then we are having problem in the modeling, because it cannot understand. It cannot do math calculation of the text. So basically, they are not calculating the actual text. They're calculating how many times this particular text show up. This particular word show up in the text. So that's it. Then we can do these things. So text, basically we move text into numbers, and the the algorithm will process the numbers. Okay. That's it for today. So next week I will try my best to do the class as well, but I will do it remotely from Sumedang with limited internet access, with laptop. It's very small laptop, but I hope it works. Okay, thank you very much. See you next week then. Thank you.
Okay,
Thank you,
thank
sir.
you.
Thank you,
Bye.
sir.
Okay.